my name is Lena, and today I will be showing you the steps of how to fill out a Punnett square. I find filling out a Punnett square very helpful for predicting offspring traits, and it can be used to reject blending theory. I will be showing this through my PowerPoint presentation slide, so I will be pulling that up right now. Today for our Think Aloud, we are going to be doing Punnett square, solving and rejecting blending theory. So for the topics that we will be covering today, we are first going to go over vocabulary and important terms relating to a Punnett square, and then we're going to solve a Punnett square, and then we're also going to learn how Punnett squares are able to reject blending theory. So for myself, I find it really helpful to get familiar with vocabulary words in the first place. Sometimes we need to know what we're even talking about, and we need to learn these words first so that we understand when they're being used. The first word we want to go over is Punnett square, and this is a tool for us to be able to predict offspring traits. And in our Punnett square, we are going to use genotypes. So these are letters, and they represent our genetic makeup. And from our genotypes, we are able to figure out phenotype, which is physical traits that we're going to have. Could be like tall or short. We also have dominant allele. This masks our recessive allele. Our dominant allele is going to be a capital letter, such as capital T for tall. And then our recessive allele is going to be a lowercase letter of T, which is short. And it only shows if there is no dominant trait. And ultimately, we need to know all these terms to reject blending theory, which is an old idea that traits mix and cannot reappear. And from our Punnett square, we will be able to see a ratio, which is the comparison of outcomes. And this ratio is going to be gauged from our genotypes and how much we have of each one. So I just want to make sure to keep these terms in mind when I'm solving my Punnett square. So as I'm setting up my Punnett square, we are using an example cross of capital T, lowercase t, times uppercase T and lowercase t again, which are heterozygous tall plants. Heterozygous meaning that the letters both look different from each other, one capital and one lowercase. I would draw a 2x2 table, and I would put the letters on top, like how they're placed right here. And I would put a capital T on top, lowercase t next to it, and then a capital T on the left side, like with the lowercase t on the bottom on it. After setting up the box, I would start combining the letters to be able to fill out the Punnett square. To make it more easy to follow, I like to start with the top left box, and that would lead to me combining capital T and capital T, which is shown by the arrows. And since capital T is for tall, capital T and capital T would make a tall phenotype. I like to make my way over to the top right and do capital T and lowercase t. When combined, that still gives us a tall phenotype because capital T is dominant. I make my way over to the bottom left, and that gives me the combination of capital T and lowercase t again. And lastly, I do the bottom right, which are my lowercase t's, which give me a combination of lowercase t and lowercase t. And ultimately, the goal of this is to be able to predict offspring genotypes and phenotypes, and then be able to explain why we got the results. For our results, we have genotypes 1 capital T, 2 capital T, lowercase t, and 1 lowercase t. This gives us phenotypes 3 tall and 1 short. And we would see the ratio of the phenotypes is 3 to 1, 3 tall to 1 short. And for anyone who might have any confusion, I like to remember that if you just see a capital T, that means that it's going to be the dominant trait, which is tall, because capital T is dominant and lowercase t is recessive. So capital T and lowercase t is going to still be tall. Now I need to think about how this rejects blending theory. And when I think of blending theory, I know it is an idea about inheritance, that Cumming's offspring are a mix of their parents' traits. And an example of this is that under blending theory, we would think that a tall plant and a short plant would only make medium height plants, and the original tall and short traits would never show up again in the future generations. Remember blending theory, I just remembered the word blend, like a mix of the parents' traits. The Punnett square rejects blending theory because if blending were true, all the offspring that we see would be medium height. But from when I worked out the Punnett square, I was able to see that there are distinctly tall and short plants. And we could see the ratio was 3-to-1 tall plants to short plants. And we also know that recessive traits appear in the next generation, so the traits are inherited as separate units and not blended. So some common confusions that I see come across and some strategies that can be helpful with that is that sometimes I find myself mixing up genotype versus phenotype, and I quickly tell myself that genotype is letters and then phenotype is traits. And another thing that can be confusing is dominant versus recessive. I like to tell myself that dominant is dominating, so dominant is like the one that would be showing. And some strategies to avoid the confusion is to remember to label which allele is dominant, and also make sure to write both genotype and phenotype for each box. This helps me be able to remember that genotype is the letters and phenotype is the trait. Also, if you don't want to mix up ratios at the end, the way I like to do it is to be able to check the ratios at the end and think to myself, does this ratio make sense? Is the amount of genotype I'm getting it correct, or is the phenotypes looking right? Does the ratio add up? So this is how I would solve a Punnett square and use it to reject blending theory. I would first start out by creating a Punnett square, which can start off as a 2x2, then filling it out, and then I would interpret the results, and I would use these results to be able to reject blending theory, which fulfills our purpose of predicting inheritance and rejecting blending theory. And I find this very useful because it shows how traits pass on, explains how recessive traits appear, and it helps us understand genotype and phenotype more clearly. Saying my thinking out loud while doing all this really helps me catch my mistakes and why following these steps are so important to filling out a Punnett square. And that is it for my presentation. Thank you so much for listening.